going on, everybody? This is my part 2 video of signal operations. In my previous video I have done the basic things. Here I am going to do the complicated one. Now let's go ahead and see how to do that. Here they are saying consider the signal, and we have a signal provided. The question is asking sketch the signal y of t is equal to x of 2t plus 3. There are two different methods we can do this. Now let's look at the first method. First method I approach in this way. Approach 1. Here what I'm going to do is first I'm going to do this time shift. How to do the time shift? First we start with x of t. That's the graph provided here. This is x of t, and then what we do is we do the time shift first. Time shift is basically we look at the values that are added with t. Here we have t plus 3. We neglect the 2 for now. Just take the t plus 3 for now, and we draw that one first, and then we do the time scale. Time scale for this one, what we do is we just multiply the 2 by t. It means we are doing the compression. Okay, x of 2t plus 3. Now let's go ahead and see how to draw the graph. I draw that one right here. Okay, here's our graph. First we have x of t. Now I'm gonna do the t plus 3. When we add 3, what's gonna happen is we are actually adding negative 3, because it's the original format is 2t minus 3. Minus 3 is the thing shifted, so we are just gonna add minus 3 for everything. So if we add minus 3 for this 2, we are gonna get a negative 5. So that's gonna be the first thing. I'm gonna draw the graph right here. So whatever the starting at negative 2, it's gonna start at negative 5 right now. We are gonna have this one starting at negative 5. I just draw the same graph, but this one starting at negative 5. And also if we add negative 3 to 0, it's gonna go to negative 3. And then if we add negative 3 to this 2, it's gonna start at negative. It's gonna go to negative 1. So I need more space. I delete this one a little bit because we are gonna have this one in negative 1 here. I delete this one and continue here. Okay, here we go. This one just ends at negative 1. And let's look at the next one. 4 minus 3. 4 plus minus 3 is going to be 1. So it's going to go after this line. After this line here. Okay, this is our graph. And it's negative 1 here. And then okay, I forgot to do one more thing. Okay, it's negative 1 here, and after that it goes down. So the graph basically shouldn't be looking like this. I delete this one and add the white color here, and it actually goes down below. So I draw that down below thing. Down below. And then it goes right here and finish at 1 here, and then it keeps on going, and here it keeps on going. Now that's the shift we made. Now let's put all the values. This one is minus 2 minus 3 minus 5. This one here is 0 minus 3 minus 3. Here 2 minus 3, that is negative 1, and here 4 minus 3, that is 1, and then it keep on going like this. Okay, now we have done the t plus 3 part. This part We have done this part right now. Now we have to do the compression, 2t plus 3. When we do the compression, what's going to happen is it's going to be exactly the same. Everything is going to be half time. When we multiply 2, we have to think like divide by 2. So minus 5 divided by 2, 2.5. So the final graph is going to look like exactly the same. I draw the exactly the same, just change the values. Okay, here we go. And here I draw the exactly the same graph. Okay, exactly the same. Okay, this is just the arrow. Okay, here we go. This is t, and here we have negative 5. This one should be negative 2.5, and here we have minus 3. That's minus 1.5, and here this one is okay. Did I made a mistake? 2 minus 3 negative 1. This line, let me delete this line here, because this negative 1 is basically this axis. This one is the negative 1. Okay, so this one should be 0.5 here, and then here 1 divided by 2. This is negative 0.5, this is positive 0.5, and then it keeps on going after that, and that's the final graph. This is approach number 1. Now we are going to do the same thing with another approach. Now let's see how to do that. Okay, let me delete all these things. Okay, I keep the question here. I delete all the things. Okay, let me see if I can make this one smaller. I want to make the whole thing smaller, so I will have more space. Okay, let me cut this file. Shit, I'm sorry about that. Okay, here we go, one more step. Okay, here I'm gonna cut this thing. Let me see if it's available. Replace that. Replace. I don't know. Oh, I don't want to mess it up. Undo. Okay, let me complete here. I start from here and do it. I'll figure it out later in my next video. Maybe I will do it better. Okay, here we have done this one in approach 1 way. In approach 2, what we are going to do is we are going to take this x of t. First we are going to do the time scale, that is multiplying by 2, time scale x of 2t multiplying by 2. Multiplying by 2 is basically like before we seen, when we multiply it's basically divides. If you have negative 2, that one become negative 1. If you have negative 1, that one become half of that, like negative 0.5, something like that. The next thing we are going to do is time shift. Time shift is x of 2, and when we do the time shift here we have to be careful, because in the first one we did the time shift first and then we did the multiplications. That's why it became easier. But if we are doing the time scale first, we have to do in a different way. Like we multiply the 2t already. Now we have to see with the adding value. We add 3 here. If I multiply with 2 what value, that will bring the t plus 3 again. So we had to put the 3 by 2 here and then close it, because if you see here I multiply 2 by t, 2t, and then 2 by 3 by 2, we will get 3 again. We have to get 3 here, right? That's why this is complicated, because if you are doing time scale first, that's going to be a little bit different like this. We have to make the equation that when we multiply by 2, it should bring the same thing again. So that's the only thing we have to be careful, and other than that everything is exactly the same. Here what we are going to do is time shift. Time shift is, if we are adding, we know that we had to move this one to the left by 3 by 2 units. If it's plus, 3 by left by 3 by units. If it's minus, right by 3 by 2 units. Since we have plus, we are going to move it to left. Okay, now let's go ahead and start the first one. X of 2t, same graph, everything divided by 2. So what we are going to have is exact same graph here, exact same graph here, everything divided by 2. Okay, let me draw the same graph first and then put the values. That's much easier. Okay, here we have the same graph, and then we divide everything by 2. If we divide negative 2 by 2, we will get negative 1. 0 by 2, 0 still. So this is going to be just 0 here, and 2 by 2, that's 1, and then 4 divided by 2, that's 2. So this is going to be the graph x of 2t. Now what we have to do is we have to shift left by 3 by 2 units. 3 by 2 mean 1.5. So 1.5, negative 1 minus 1.5, we are going to have negative 2.5. Okay, I draw the graph here, and then I start from 1 by 1. Okay, now this one goes up at negative 1 plus negative 1.5, negative 2.5. So it's going to go up at negative 2.5. Now this one goes down at 0. 0 minus 1.5, we are going to have negative 1.5. This one drops at negative 1.5. And then here we have 1. 1 minus 1.5, we are going to have negative 0.5. So it goes up and drops at negative 0.5 here. And then this one goes down and then ends at 2. 2 minus 1.5 is 0.5. So it's going to go and end at 0.5, and it keeps on going like this. Now if you compare my previous graph and this graph, it's the same thing. We did in different methods. Let me put the values. Minus 1 plus minus 1.5, minus 2.5 here. 0 minus 1.5, that's negative 1.5, and then 1 minus 1.5, negative 0.5, and then here we have 2 minus 1.5, that's 0.5, and this is t, and this is 1, and that's it. That's how we do the signal operations, doing these two different approaches. If we are doing the time shift first, it's much easier because we don't have to make graph equations like this. We can directly go about it. But if we are doing the time scale first, we have to make an equation that when we multiply with whatever the number we used to compress with, should give the same equation. Okay, that's the only thing we have to consider, and other than that everything is same. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.